Welcome back. This is lesson 18.4. In the previous lesson, we wrote code to run the binary search, and in this lesson, we'll turn that code into a binary search function. So in this lesson, we'll write the function, call the function, and look at how it can be altered by using either parameters or global variables. To remind you how the binary search works, we find the midpoint of the list, we slice the list in half, take the upper or the lower slice and keep slicing until we have a list of only one item. At this point, we have either found our item or it is not in the list at all. This is the code to carry out the binary search. It's the complete code, apart from the code to create the random list of items called mylist. So if you haven't already written that code, then you can do that now. So here I've copied the binary search code into a binary search function. And at the end of the code, instead of printing that the search term is found or not found, I return true or false. You'll see that I've passed mylist as a parameter to the binary search function. Do you know why that is? We don't have to pass mylist as a parameter when we're doing the linear search, but we do have to pass it as a parameter when we're doing the binary search. Can you work out why that is? I'll tell you in a moment. The reason is because we change the value of mylist within the function. We slice it in half, it gets smaller and smaller. If we're changing the value of a variable, we need to pass it as a parameter. If we're not changing it, we're just looking at it, we don't need to pass it as a parameter. So the binary search function changes the list, and that's why we have to pass the list as a parameter. This also changes the way that we call the function in the main program. So let's have a look at that now. When we call the function, we have to call it with two parameters, the target and mylist. And then we capture the returned value. Here I've captured it as a variable called found. If found is true, I'll print that the value is in the list. Otherwise, I'll print that the value is not in the list. So I've captured the return value as a variable called found. Can you think of a way to simplify this code to use less lines to achieve the same result? I'll show you one way of doing this in the next slide. One way to simplify the code is to use the function as an expression in the header of the if statement. So bin search is a function that returns true or false, so we can use it as a Boolean expression in the header of the if statement. So if bin search returns true, we'll print the value is in the list, otherwise we'll print the value is not in the list. So we've somewhat simplified the code. We can use a similar method to simplify the code inside the binary search function itself. Here's a somewhat simplified version of the binary search function. I simply compare mylist 0, the final remaining item in the list, to the target value. That's a comparison. It uses a relational operator, so it's an expression with the value true or false, and I can simply return the value of that expression to the main program. So that's slightly simplified the binary search function as well. So see if you can simplify your code using those tips. So we had to pass mylist to the function as a parameter. The function, the binary search function, reduces the list. It slices it in half and half again until it's down to only one item. However, of course, a parameter in Python is a copy of the list that works. It acts like a local variable within the function. So it doesn't change the original list in the main program. So we can prove it. I can print out my list before the search, and I can print it out at the end after the search is over. And you'll see that it prints out, it's an identical list each time. All the slicing that happened inside the procedure won't affect the list at all, because it all happens, it's all done to a copy of the list. A parameter is a copy of the value. It would be quite different if we passed mylist as a global variable rather than as a parameter. I've done that here so that you can see what happens. I've taken mylist out of the list of parameters. It's not a parameter anymore. It's a global variable. Try making this change, and remember to change the parameters in the main program as well, because bin search now only uses one parameter. If we run the program having made this change, look what happens to the list. The list in the main program is cut down to a single value. In other words, the list has been ruined by simply searching through it once. So what can we conclude from this? As we know, binary search slices the list. It's important, therefore, that you use a copy of your list, because otherwise you've destroyed your list of values through one search. It's important, therefore, to put the binary search code into a function rather than have it in the main program, and pass the list by value as a parameter so that you change a copy of the list. When you're using the binary search, you should try to avoid using global variables, because your list will be cut down to a single item. Some programming languages let you pass parameters by reference, and this would be just as bad, because when you pass by reference, you give the function access to the original values, so your original list would be destroyed. There are ways to avoid these problems if you're using a language where you are stuck with passing parameters by reference, and we'll look more about that in the next lesson, other ways of doing the binary search to avoid these problems. So in this lesson, you've turned the binary search commands that we learned last lesson into a function, and we called the function from the main program. We looked at what happens if we call the function with a parameter or if we use a global variable. So as an exercise, write the binary search function and try to make the code as simple and readable as you can, and try it out with the use of global variables, because you'll easily see why that's not a good idea. In the next lesson, we'll look at some alternative ways of writing the binary search function that will avoid some of these problems. So, bye for now.